Okay, my name is Allison Nims, and my favorite topic that we covered this semester was circuits. So I already had gotten started with this one, but there was an ambulance driving by, so we're going to redo it. But the question says that the current shown in the figure for the resistor 1 equals 50 ohms, resistor 2 is 20 ohms, resistor 3 is 35 ohms, resistor 4 is 10 ohms, resistor 5 is 68 ohms, and then current 1 is 0.111 amps and current 2 is 0.142 amps, and the batteries are ideal. So before I started, I put all of my values out to the side for all the resistors and for both the currents. And then to determine the voltage flowing from both of the power sources, I divided the resistor into the circuit into A and B, so it's a little easier to set up the math. So for voltage 1 coming from this power source, you're going to multiply the current flowing through this side of the circuit times all the resistors on this side of the circuit added together. But since resistor 4 is in the middle, you also have to multiply that one by the second current because it gets the power from both. Then if we plug in values, R1, we can just use them from here instead of going back to the problem. R3 is 35, 10, 0.142, R4 was 10. Okay, now, so I put that in my calculator here, 0.111, so this is the current for 1 times the resistors added together plus the current for 2 times the resistor for just 4, and that was 11,965. And this is in volts. And then for this side of the circuit, it's the same concept, just using the second current we're provided. And then we still have to account for resistor 4 getting power from both. R2 is 20, R5 is 68, R10, 0.10 plus. Okay, so we're gonna plug that just like that into our calculator. So 0.142, 20 plus 68 plus 10 plus 0.111, yep, multiplied by 10 equals 15.06 or 0.026. Okay, perfect. Then we want to know what is the potential difference across R4. So that's part B. And for that, we're solving for delta V using the equation delta V equals current times resistor, or your resistor value. Since it's specific to R4, and we know R4 is in the middle, being impacted by both the currents, we're going to add our currents together for I and multiply them by the resistor value of only 4. So delta V equals 0.111A plus 0.142A multiplied by 10. Now we'll do that here. Point 111 plus 0.142 multiplied by 10. 2.53, and we're still in voltage. And this is how I would solve this problem from our mock exam that I used to study for the final. Thank you.